Electrons in hydrogen-like atom Z is equal to 3 make transitions from the 5th to the 4th orbit and from the 4th to the 3rd orbit. The resulting radiations are incident normally on a metal plate and eject photoelectrons. The stopping potential for the photoelectrons ejected by the shortest wavelength is 3.95 volt. Calculate the work function of the metal and the stopping potential for the photoelectrons ejected by the longer wavelength. So from here I can start like this, that the value of Z is equal to 3 and the working formula which we are using is going to be E, which is equal to minus 13.6 Z squared by N squared. So now over here we are first of all calculating the value corresponding to N equal to 5. So E5 can be written as minus 13.6 Z square, that means 3 square upon 5 square, and we obtain a value equal to minus 4.896 electron volt. Next we are calculating energy corresponding to N equal to 4, and we can put the value in the same equation, minus 13.6 Z square by 4 square, and we obtain value equal to minus 7.65 electron volt. The next we are looking for the N equal to 3 orbit. So we can put this as minus 13.6 Z square by 3 square, and the value is obtained as minus 13.6 electron volt. So now if I calculate the energy involved in transition, so I can say that the energy involved in transition, or the delta E, can be calculated by subtracting the values, that is E5 and E4, and we obtain the value equal to 2.754 electron volt, and the another transition is from E4 and E3. So this value can be calculated as 5.95 electron volt. Now considering these two values, I can say that since energy is inversely proportional to wavelength, so I can say that the larger energy is corresponding to shorter wavelength, and this smaller value is corresponding to longer wavelength. So now the question is saying that the stopping potential for the photoelectrons ejected by the shorter wavelength was 3.95 volt. So from here I can say that for the incident energy of 5.95 electron volt, the stopping potential was equal to 3.95 volt, or I can say that the kinetic energy for the maximum kinetic energy of the emitted photoelectron is equal to 3.95 electron volt. So from here I can calculate that stopping potential can be calculated using the expression E kinetic energy maximum is equal to incident energy minus work function, that is 3.95 is equal to 5.95 minus 5, and from here we obtain phi is equal to 2 electron volt. So the value of work function is equal to 2 electron volt. Now in the next part the question is asking us to calculate the stopping potential for the photoelectrons ejected by the longer wavelength. So for the longer wavelength I can calculate the value of kinetic energy as incident energy, that is 2.754 minus the value of work function, that is 2 electron volt, and we obtain the value of maximum value of kinetic energy is equal to 0.754 electron volt, and hence I can say that the stopping potential will be equal to 0.754 volt. So these two are going to be the answer for this particular problem.